Welcome back to Learning with me, Ms. Killen, here at MPB. We are in the middle of our Unit 10, Statistics with One Variable. Today we're looking at Lesson 5, Measurements of Data's Distribution. I can compare measures of center. We're looking at S-ID.2 in Unit 10. So let's go ahead and dive in and see what we've got. Okay, how to describe distributions. We have the center of something, we're looking at the shape of something, and then the spread of this data. All three of these words give us crucial information when we're looking at this data sets. So, all measure of center of data. We're looking at the mean. It's the average of the set. We add all of them up and then divide by the number that we have. Our median, which is the middle number of the set, and we've learned how to do those ticks to find if it's an odd, or we also found out how to find the median if it's an even. And then the mode, it's the most frequency that we see. It's the most that has that number in that data set. So if we use data on how much Miss Cumberland's cheerleaders sent Snapchats on Friday before the game, we could first show the data in a list and then a dot plot. So let's go ahead and work. I'm going to work it here on the board while you work on your paper, and let's see what we can find. So we have the data down here at the bottom, and we've already put this data set in numerical order, as we always should. So the first thing we're going to do is we need to answer some questions. What is the value of the median? So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's even. So let's go ahead and see if we can figure out how to find that median. So I'm going to mark off 1, mark off 1, mark off 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. I'm going to add these two and divide by 2. And the median, we're going to say, is 7. So now it also asks me, so we have 7 here. What is the value of the mode? Now we know that our mode is the one we see the what? The most. So in this data set, what's the one that we see the most? Well, let's see. 5, I see it's 1, 2, 3. I have 12 at 1, 2, 3. So my mode, I could say, is what? I would say it's 12 and 5. All right, what is the value of the mean? Now we learned the mean is the average. So what I'm going to do is I'm going to take all of these, I'm going to add them together and then divide. So let's do that. So we're going to add 2, 3, 5, 5, 5, 6, 7, 7, 10, 12, 12, 12, 14, and 20. We put this in our calculator, and the mean we get as 9.16 repeating. Now, do you notice a shape? So let's go ahead and make this dot plot. So I've got 2, 3, 5, 6, 7, 10, 12, 14, and 20. So I had 1, 2, 1, 3, 3 5s, 1 6, 2 7s, 1 10, 1 2 3 12s, 1 14, and 1 20. So do I notice any specific shape? Not really, because if we look, it kind of looks like this. So there's not really a definite shape to this data set. So I would say there's not a noticeable shape to my data set. That's what I would say. All right, so let's look. It says definitions. So when I have a definitions of the shape of my data set, it's symmetric. Symmetric distribution is a data set whose graph shows symmetric or symmetry along the mean. Remember, the mean is the average. All right, it says the shape of a dot plot can add important information about the distribution. If we see a symmetrical shape, it says to follow a normal distribution. The bell shape or the bell curve means most of the points are in the middle. So if I looked at this, it looks like this, right? So I have 2, 3, 4, 3, and 3. So there is a curve to it, and it's really symmetrical if we look one more time, it's really symmetrical about right here. Now, it's not exactly because our 60 only had 2, but I do see kind of like that bell shape or that bell curve that we were talking about. Okay, so it says that it tells us a lot of important information in this. So this spread of the data is kind of even. Okay, it's spread evenly amongst the data with our mean being the most or the median. All right, so let's see. Now, if something is skewed, means that there's more emphasis on one side of our bell curve than the other. When we look at data sets that are not symmetrical, we say that they are skewed. When the tail where the tail lies determines how we say it is skewed. So in a normal distribution, here's our median. 50% of our data is on one side and 50% of our data is on the other. Now, if I have a skewed data set, and here's my tail, which is smaller amounts of data, so wherever the tail is the way it is skewed. So since the tail is on the right, we would say it is right skewed or skewed right, or skewed right. That's the same thing. And then here, the tail is right here. And then here's the median. So the majority of our data is over here. So we would say this is skewed left or left skewed. So the majority of our data is on one side and the little part of our data is on the other side, which makes the tail. And wherever the tail lies says, hey, this is how we're skewed. So that's what those skewed data distributions look like. All right, but for the best measure of center for a skewed data set is to use the median. So it says when considering how to tell if the data is skewed, the more appropriate measure for the center is the mean of the data set. And then the best way is to use the median, because sometimes the mean or the average is not going to be the median. So right here when we see skewed right or positive skew, here's our mode, which is the most. Here's our mean, which is a little off from our median. So that means it's going to have a positive skew, because remember, the skew is to the right. When we look at our number line, our positive is to the right, our negative is to the left. So let's go over here and look at the negative skew. Our mean is on the left side. So then it's going to be skewed left. It's also going to have a negative skew. Obviously, if everything is symmetrical, it's a symmetrical distribution. So for a positive skew, my mean is on the right. For a negative skew, my mean is on the left. So that is something that we need to make sure that we're looking at when we're putting these points on a dot plot, where that mean is located, where the median is located, where the mode is located, to tell if it is positive or negatively skewed. All right, so it says, time for you to master. So I want us to take what we've learned and look at Mr. Bozeman's survey. Mr. Bozeman surveys his freshman and sophomore art students. He wants to know how long they spent on preparing for their art presentations that is next week. He tabulates all the results and constructed a dot plot to display data for both groups. So let's see what we've got first. We've got our freshmen in blue, we've got our sophomores. So we see the different distributions, we see if we see patterns and what they could mean. So with us analyzing these, do you see a pattern? Do you see maybe a skewed right or a skewed left or a symmetrical distribution? So with analyzing these graphs, we want to answer what the value of the largest median of the two groups, what's the value of the largest mean of the two groups, and then I want to describe the difference between the number of minutes the two groups prepared compared to the center and the shape of their group. So Pause the video, you and your table partner, go ahead and work this out, noticing the graphs, noticing if they're skewed, if they're symmetrical. See what you can come up with, then come back to me and let's see what we got. All right, so now that we have worked these, let's see if we can compare what we have found. So I'm going to grab my calculator. Now, it says, what is the value of the largest median? So when you looked at these, what did you find as your median? Now, you can obviously check off from one side to the other, coming to find out what the median is and stuff like that, or maybe you calculated and looked at the different points. But when you found the largest median of these two groups, what did you come up with? Exactly right. You had 50 as your sophomores. They have the largest median. Now, what is the largest mean of the two? Now, remember, the mean is my average. How did you come up with the average? Well, what I did is I took all of my points and I added them together, then I divided to find my average. So, who has the largest average? Absolutely. My sophomores do. All right, so then it says describe the difference between the number of minutes the two groups prepared, and then compare the center of the shape of the groups. Now, when I look at this, I'm seeing this, and then I see this as my shapes. So what can I say when I compare them? I think this one is kind of skewed right. I would say is a little bit more skewed right because my tail is kind of coming down here to the right. Now when I look at my sophomores, I really can't say that it's skewed because I have a good majority of my data and then I have a good majority of my data over here. So I would not say that it is skewed at all. That's how I'm looking at these. This is how I'm comparing this information. Now, when you have these different types of questions and you're having to reference back to these graphs, use a good common judgment. Can I make a tail? Do I see a positive or negative skew? Do I know how I'm finding those medians? Do I know how to find those means? Make sure that you're understanding the operations that these problems are asking you. All right, so you always want to make sure that you're using good common calculations when looking for those different points that it's asking for. Something I don't want us to forget. When we are comparing measures, what's the center? Where does the center lie on those different graphs? Where's my median at? Where's my mean at? What they look like when they compare. Okay, what type of shape is it? Is it symmetrical? Do I have a skewed tail? And which way is that tail sitting? And what does the spread tell us? Okay, how far is the range between the smallest and the largest? Or is it all differently compacted? So you have to really look at those graphs and analyze the information it's given. We're almost to the end of our Unit 10, and I'm having a great time with this statistics with one variable. So, as always, thank you for enjoying, and thank you for being here with me at MPB, and have a great day.